Hello, thank you so much for tuning into my YouTube channel. In today's video, I want to talk about linear regression and how we could use it to solve our computer vision problems. At the end, I'm gonna also show you guys a practical example. Let's get started. As I said, this video is a short tutorial on linear regression in Matlab. Linear regression is to solve the problem of y equals m multiplied by x, where matrix M comprises the linear regression coefficients. This equation on its own is not defined. To have this equation solved, we need to first have access to a set of data for which we have both x and y. After that, we could use this equation to obtain the values of y for any values of x. X and y are not always square, so we can't just use the following equation, which is m is equal to y multiplied by inverse of x. The reason for this is inverse is only defined for square matrices. Here we need to use pseudo-inverse, shown as follows. Therefore, now that we have specified the matrix M, we could predict the values of y for any values of x. Now let's do one real example in Matlab. Before going to Matlab, let's say we have two images of the same scene, but one of them has become yellow somehow, shown as follows. The one on the right. In other words, it has become corrupted. So now let's say I have another yellow image that I'd like to get its original color, shown as follows. To obtain the original look of this image, I could use pseudo-inverse in a way that I first extract the relationship between the yellowed and the colored images showed here, the yellowed and the colored image. And then I apply the same relationship to this yellow image, potentially helping me predict its original look. In other words, I have to first use the yellow image and its corresponding colored image to specify the matrix M. I use this equation to have matrix M specified. In other words, the pseudo-inverse of the yellow image multiplied by the original image would give me the matrix M. And now I could use matrix M to predict the original look or the colorful image corresponding to this yellow image. Very easy. Let's go to Matlab to show you guys the coding that I have done for this problem. So here's the coding. First we read the original image and then we read the yellow image. I'm gonna resize the yellow image so that it will be the same size as the original image. Then I'm gonna reshape the two images so that it would be n by 3 or n by 3 here. And I would use this equation to specify matrix M using pseudo-inverse. Now I have another yellow image for which I'd like to predict its original look. I read in this image and I would change it to double. I resize it so that it would have the same size as the above images. And then I would reshape it here. And then I multiply it by matrix M that would give me the original look of the corrupt image. And here I will show the original image and its yellowed version. Let's run this and see what happens. Yeah, this is the original look of this image. And you can see that we were able to predict its original look as shown here at a very acceptable level. I also have the original image of this one. Let's see how well it is compared to this one. And here we are comparing this predicted image using pseudo-inverse with its original version. And you can see that pseudo-inverse hasn't done a bad job predicting this image from this yellow image. Yeah, that's about it. Using a simple linear regression, we were able to predict the original look of a yellowed image. Thank you so much for watching this video. I hope you liked it and you were able to get something out of it. If you liked it, I would appreciate if you would subscribe to my channel and also share the video with your friends. Thank you and have a nice day.